Lesson 22, Web Services and the REST and SOAP protocols. In this lesson, you will learn the basics of web services and how to implement them using the Representational State Transfer, or REST, and Simple Object Access Protocol, or SOAP, protocols. The topics we will cover in Lesson 22 are Introduction to Web Services, REST or Representational State Transfer, using REST in practice, web services using SOAP, the SOAP protocol, using AJAX and SOAP, and reviewing SOAP and REST. You are familiar with applications in which server-side scripts are called to carry out tasks. Devised data structures are used to transfer the information and written routines to handle data transfer both to and from the server. Suppose, though, that you wanted to make your server-side programs more generally available. Perhaps you can imagine that several different web applications might interface with such scripts for their own purposes. As well as browsers requesting pages directly, perhaps other applications, for example, AJAX applications operating via XML HTTP request calls, might also make data requests and expect to receive in response data that they can understand and manipulate. In these kinds of cases, it would be beneficial to have some form of standardization in the interfaces that your program makes available. This principle provides the basis of what have come to be known as web services. As an example, suppose that our server application produces XML formatted weather forecast data in response to a request containing geographical information. The nature of this type of service makes it broadly applicable. Such an application might have a wide variety of clients, ranging from simple web pages that present weather forecasts in their local area to complex aviation or travel planning applications that require the data for more demanding uses. This type of service is just one small example of what a web service might be capable of doing. Thousands of web services are active on the Internet, providing a mind-boggling array of facilities, including user authentication, payment processing, content syndication, messaging, and a host of others. In general, a web service makes available an application programming interface, or API, which allows client applications to build interfaces to the service. Although any Internet protocol might be used to create web services, XML and HTTP are popular options. A number of protocols and techniques have emerged that can help you create and utilize web services. This lesson looks at perhaps the simplest of those, called REST or Representational State Transfer, and SOAP, the Simple Object Access Protocol. Next, we will highlight in particular how they may be useful in AJAX applications. REST is centered on two main principles for generalized network design. Resources are represented by URLs. A resource can be thought of as a noun and refers to some entity we want to deal with in the API of a web service. This could be a document, a person, a meeting, a location, and so on. Each resource in a REST application has a unique URL. Operations are carried out via standard HTTP methods. HTTP methods such as GET, POST, PUT, and DELETE are used to carry out operations on resources. In this way, we can consider such operations as verbs acting on resources. To understand how and why we might apply these ideas, let's look at a hypothetical example. Suppose that we have a web service that allows writers to submit, edit, and read articles. Applying so-called RESTful principles to the design of this application, the following occurs. Each submitted article has a unique URL. For example, we only require that the URL be unique for each article. For instance, this URL also fulfills this requirement. To retrieve an article to read or edit, our client application would simply use an HTTP GET request to the URL of the article in question. To upload a new article, a POST request would be used containing information about the article. The server would respond with the URL of the newly uploaded article. To upload an edited article, a PUT request would be used containing the revised content. HTTP delete would be employed to delete a particular article. In this way, the web service is using an interface familiar to anyone who has used the World Wide Web. We do not need to devise a library of API methods for sending or retrieving information. We already have them in the form of the standard HTTP methods. An important issue concerning the use of the HTTP GET request in a RESTful application is that it should never change the server state. To put it another way, we only use GET requests to ask for information from the server, never to add or alter information already there. Post, put, and delete calls can all change the server status in some way. All server exchanges within a RESTful application should be stateless. By stateless, we mean that the call itself must contain all the information required by the server to carry out the required task, rather than depending on some state or context currently present on the server. We cannot, for example, require the server to refer to information sent in previous requests. Let's expand on the example quoted earlier involving our articles web service. The list of available articles is a resource. Because the web service conforms to REST principles, we expect the service to provide a URL by which we can access this resource. Because we are querying information rather than attempting to change it, we simply use an HTTP GET request to the preceding URL. The server may return, for example, this XML. Because this is another request for information, we are again required to submit an HTTP GET request. Our web service might perhaps allow us to make a request to the following link and receive this in return. In this case, we need to issue a POST request rather than a GET request. In cases similar to the hypothetical one outlined earlier, it is likely that the server will assign the ID value of a new article, leaving us to encode parameter and value pairs for the title and author elements. Leading online bookseller Amazon.com makes available a set of REST web services to help developers integrate Amazon browsing and shopping facilities into their web applications. By first creating a URL containing parameter value pairs for the required search parameters and then submitting a GET request to this URL, the Amazon Web Service can be persuaded to return an XML document containing product details. We may then parse that XML to create DOM objects for display in a web page or to provide data for further processing as required by our application. Let's look at this in practice by developing a REST request to return a list of books. Many types of searches are possible, but in this example, we request a list of books published by Sams. We start to construct the GET request with this base URL. We then need to add a number of parameter value pairs to complete this request. Submitting this URL, we receive an XML file containing details of all matching books. The whole is not reproduced here. There are more than 5,000 titles, but this listing shows an extract from the XML file, including the first book in the list. Clearly, we can now process this XML document in any way we want. For example, you could use JavaScript DOM methods to select information from the XML document and place it in page elements added to the DOM of our document. You know already that the XML HTTP request object has methods that allow you to directly deal with HTTP request types and URLs. Accessing RESTful web services is therefore simplified to a great extent. Because you know that each resource exposed by the Web Service API has a unique URL, and that the methods made available by the service are standard HTTP methods, it becomes a simple matter to construct the required XML HTTP request calls. The prospect of being able to access a wide variety of web services from within AJAX applications and use the returned information within those applications is attractive, even more so if you can use a consistent and simple interface protocol. In the last section, we discussed web services and in particular saw how the REST protocol can be used to provide a consistent application programming interface to such services. REST is a good example of a protocol designed to operate with resource-oriented services, those that provide a simple mechanism to locate a resource and a set of basic methods that can manipulate that resource. In a resource-oriented service, those methods normally revolve around creating, retrieving, modifying, and deleting pieces of information. In the case of REST, the methods are those specified in the HTTP specifications: GET, POST, PUT, and DELETE. In certain cases, however, we are more interested in the actions a web service can carry out than in the resources it can control. We might perhaps call such services action-oriented. In these situations, the resources themselves may have some importance, but the key issues concern the details of the activities undertaken by the service. Perhaps the most popular and widely used protocol for designing action-oriented web services is SOAP, the Simple Object Access Protocol. SOAP began in the late 1990s when XML was itself a fledgling web technology and was offered to the W3C in 2000. SOAP and another XML-based web service protocol called XML RPC had a joint upbringing. SOAP was designed essentially as a means of packaging remote procedure calls into XML wrappers in a standardized way. Numerous enterprises contributed to the early development of SOAP, including IBM, Microsoft, and Userland. The development of SOAP later passed to the XML Protocols Working Group of the W3C. SOAP is an XML-based messaging protocol. A SOAP request is an XML document with these main constituents: an envelope that defines the document as a SOAP request, a body element containing information about the call and the expected responses, optional header and fault elements that carry supplementary information. Let's look at a skeleton SOAP request. Note that the SOAP request is an XML file which has as its root the envelope element. The first line of the envelope looks like this. This line declares the XMLNS:SOAP namespace, which must always have this value. The encoding style attribute contains information defining the data types used in the message. Next appears the header element, which is optional but must, if present, be the first element in the message. Attributes defined in the header element define how the message is to be processed by the receiving application. The body element of the SOAP message contains the message intended for the final recipient. The serialized method arguments are contained within the SOAP request's body element. The call's XML element must immediately follow the opening XML tag of the SOAP body and must have the same name as the remote method being called. The body may also contain a fault element, but no more than one. This element is defined in the SOAP specification and is intended to carry information about any errors that may have occurred. If it exists, it must be a child element of the body element. The fault element has various child elements, including fault code, fault string, and detail, which contains specific details of the fault condition. Let's see how a typical SOAP request might look. In the example, the M:"GetInvoiceTotal" and M:"Invoice" elements are specific to the particular application and are not part of SOAP itself. These elements constitute the message contained in the SOAP envelope. Let's see what the SOAP response from the web service might look like. A SOAP message may be transmitted via HTTP GET or HTTP POST. If sent via HTTP POST, the SOAP message requires at least one HTTP header to be set. This defines the content type. After a successful SOAP exchange, you would expect to receive the SOAP response preceded by an appropriate HTTP header. To use SOAP with AJAX, you need to perform a number of separate steps. 1. Create the SOAP envelope. 2. Serialize the application-specific information into XML. 3. Create the SOAP body containing a serialized version of your application-specific code. 4. Send an HTTP request via the XML HTTP request object containing the SOAP message as a payload. The callback function then needs to be responsible for unpacking the SOAP response and parsing the XML contained inside it. How might the resulting code look? Let's look at an example using the fictitious SOAP web service of the previous example. Here we have constructed the entire SOAP envelope in a JavaScript string variable before passing it to the send function of the XML HTTP request object. The value returned from the server needs to be parsed first to remove the SOAP response wrapper and then to recover the application data from the body section of the SOAP message. Over the course of this lesson, we've looked at the REST and SOAP approaches to using web services. Although other web service protocols exist, a significant REST versus SOAP argument has been waged among developers over the last couple of years. Let's summarize the similarities and differences between the two approaches. REST leverages the standard HTTP methods of put, get, post, and delete to create remote procedure calls having comparable functions. Web service implementations using the REST protocol seem particularly suited toward resource-based services, where the most used methods generally involve creating, editing, retrieving, and deleting information. On the downside, REST requires a little more knowledge about the HTTP protocol. The SOAP protocol adds substantial complexity with the necessity to serialize the remote call and then construct a SOAP envelope to contain it. Further work arises from the need to unpack the return data from its SOAP envelope before parsing the data. These extra steps can also have an impact on performance, with SOAP often being a little slower in operation than REST for a similar task. SOAP does, however, make a more complete job of separating the remote procedure call from its method of transport, as well as add a number of extra features and facilities, such as the fault element and type checking via namespaces. In this lesson, we considered web services using the REST and SOAP protocols. Either style of web service can be used via XML HTTP requests, though they differ somewhat in the complexity of the code involved. You can now test your knowledge in the quiz area, access the scripts we learned in the lab, or go through the lesson again. The choice is yours.